and the range of this function. What about calculating the range and domain? Calculate the domain and range of that function. And calculate the domain of this function. Calculate the domain and range.
I'm gonna ask her actually.
Anybody got this one?
Yeah.
What's the domain?
All real numbers x cannot equal 4. All real numbers x cannot equal 4.
Say that again.
All real numbers x cannot equal 4.
Why can x not be 4?
You can't have a 0 in there,
Have you never taken the square root of 0? Have you ever taken the square root of 0?
Yeah.
What'd you get? It was 0, didn't you? So that's not the correct answer.
No, it's all real numbers. All real numbers less than or equal to 4. Greater than or equal to 4.
Well, hold up. I didn't say you were wrong. I think you're right.
Because I know that you can't go to a negative, like it can't be a 5.
Yeah, because
then you have a complex solution.
this has to be what?
So-
This has to be
The
greater
answer
than.
is all numbers greater than or equal to 0.
Oh, yeah.
Yeah, greater than or equal to 0. So this says what? Minus x is greater than or equal to minus 4. X is less than or equal to what? 4. All real, you got it right, like I say. It's just one of those, because this was backwards.
Yeah.
It would have been the other way around if you had it, yeah, had written this the other way. Now that's the domain. Does everybody see what the domain is? How about the range?
All real numbers greater than or equal to 0. I thought you said the range for the first one.
The range is what?
All real numbers greater than or equal to 0.
Yeah, all real numbers greater than or equal to 0, because if you actually put what numbers are here, like say, if you put a 4 there, that's 0. And so you know it's gonna do what? It's gonna start up and go at what? It'll look something like, when x is 4, 1, 2, 3, 4, it looks like that. So it's from 0 all the way up to ever and ever and ever.
Yeah.
Does that make sense, everybody? Now, the range sometimes is sort of difficult to find. That's why I didn't ask you to find the range on this one over here. What about the domain on this one?
All real numbers.
All real numbers. All real numbers. You cannot possibly make that denominator 0. I don't care how hard you try, you'll never make it 0. That make sense? So all real numbers. Now, don't worry about working one like this for the range. The range is a pretty difficult one to find on a problem like that, unlike this one over here, where you can just look at it and see. For example, if you had this problem, f of x is equal to, say, x squared minus 5x what is this? Let's see here. Make this plus 20, like that, for example. If you had a problem like that,
Well, let's find the range of the domain.
if you, well, finding the domain in that problem is real easy because it's a polynomial. There's no restrictions anywhere. It's easy to see that you can use what? Every number in the world. But what about the range? What about the range? The range may be a little bit different. How would you go about finding the range in this problem?
On the vertex?
Exactly. All you have to do is just take and find the vertex of this problem. If you found the vertex, you know, and let's see if we can do this. Let's see if we can find, you know, we know we can factor this into what? Like this, x minus 5, x minus 4 equals 0. So you know when it's what? When it's 5 and 4. 1, 2, 3, 4, 5. 5 and 4. And then it does something like this, right? So it has to come down here, somewhere in this neighborhood. So you know good and well, 4.5 is the first number of the vertex, okay? And if you plug that back in, whatever you get, I don't know, we'll pretend we plugged it in and say we got a minus 8 or something, I don't know. But you notice that your range would be where? From minus 8 all the way to what?
Infinity.
Infinity. That would be the range. That makes sense? How you can go about finding the vertex on a quadratic, and that would tell you the range. For example, if the quadratic looked like this point right here would say 3, 8, and it went down like this. If you looked at that range, you cannot find a y value any bigger than 8 on that whole entire picture. Every y value on that picture is less than 8. And the range is the y values. The domain is the x values. Am I making sense when I say that? The domain is what numbers are you allowed for x. And the range is what you get back for y. And you can look at that problem, look at it this, it'd be hard to tell which was the range until you did what? Found the vertex. Once you found the vertex, like over here, for example, you know it has to be from this number all the way up. And over here, the range would be what? 8 is the biggest number, all the way to minus infinity.
Yeah.
Okay, I can't remember what, we worked, a couple of days ago, we worked 2 problems, didn't we? We worked one of the defense or whatever. We worked the fence problem, where we put the fence up. We also worked the what, the cardboard box one, right? Let's see if I can find another problem that, let's see, let me have you try this one, everybody. This one is, yeah. Let's try to find the value of x. Try to find the value of x. I'm going to solve that equation for x. Let's see how close you get to solving that equation for x. Anybody got it? Close to it? Everybody got it?
27.
Anybody else get it?
Got the same thing. Got the same thing.
27?
Yeah.
Anybody not get 27? Anybody tell me why that's the wrong answer? No, it's actually, you're close, but it's really plus or minus 27. And the reason being is, you see this right here? Because that's an even number. Be real careful that you don't miss that. If it's an odd number, you don't care. So this would actually be what? This was 2x to the 2/3 equals to, I'm gonna put the 43 over here. This becomes 43 minus 25. So 2x to the 2/3 is equal to, I don't know how much is this? 18. Okay? Now we got x to the 2/3 is equal to 9 because I'm dividing through by 2. So if you have x to the 2/3 is equal to 9, how do you make this x? How do you make this just x?
Do the 3 halves.
How do you make this just x?
Take it to the 3 halves. Do it to the 3 halves.
Yeah, you raise this side to the 3/2 power. So you have to raise this side to the what? 3/2 power. Does everybody see that? So this becomes just an x. And because that was a 2 up there, be careful that it's what? That you don't miss the plus or minus 27. Everybody okay with that? Okay, race this away. Dog. Yeah, probably, just a second, give me 1 second here. Minus 5. What I want you to practice doing is this. Take this equation, and I want you to apply what they call the difference quotient to it. Now that's, I hate that term because it's really applying this to it, okay? They call this the difference quotient. I want you to apply this to this problem right here, and let's see what you get. Mr. Wilson, yours doesn't count. All right? You know what I'm talking about, right? Mr. Wilson doesn't count. Apply that difference quotient to that problem. Let me remind you of what you have to do. Okay? First of all, you must do this part right here. See this? You must do that first. And then you subtract the function from what you get and divide that by h. Everybody see what I'm saying? do this first to that problem over there. It was quite simple. Just do that to the problem, and then minus the function itself. And when you minus that function, you make sure you put it in what? A bracket.
Two x plus h minus two.
What now?
2x plus h minus 2.
Who said that?
Me, is that not right?
You got what?
Is that not right?
What'd you get?
2x plus h minus 2?
Let me see how you got it.
Can't show you that. I don't know yet.
Huh?
I don't know yet. Everything's just out of the place. I don't put everything in one place.
You just wrote that down. What you got? Yeah, good. Don't put this out there.
I did it in my head.
Had it? Had it? But, this should be right. What you got? You got it? Okay. Yeah, that's right.
He's literally like.
We'll do this right here. So we'll do this first, right here. See that?
H minus
Do this first.
2x plus h minus
That
2.
way you have to do what? Every single place you see an X, you'll put in one. X plus X.
Nothing's not there.
Does everybody see this? Let's do this, everybody. Let's just do this part right here first, okay? Let's do this part first. Well, that says what? That x plus h squared minus 2x plus h minus 5. This right here is this. See that? I just plugged in an x plus h every single place that I saw an h, an x. Okay? Everybody with me still? So now, if I just do this, let's go ahead and do this part right here. Remember, this is this right here, just this, just that. So if that is the case, then this becomes x squared plus 2xh plus h squared minus 2x minus 2h minus 5. Does everybody see that that's what I get when I do that work? Now, if you don't, everybody follow me? And now we're being asked to do what? Subtract the function, okay? Subtract the function. Remember I told you to put that in what? In brackets. And the function is what? X squared minus 2x minus 5. This is all divided by what? H. So, everybody see that? Well, if you take note of this, watch what happens when I knock the brackets down. Look what happens when I knock the brackets down. Everybody inside changes signs. That used to be a plus x squared. It's now what? Minus x squared plus, take down the brackets. Everybody still with me?
Yes.
Now, look at this. This goes away with that. the 2x, and the plus 2x, the minus 5, and the plus 5 goes away. And now I am left with nothing more than 2xh plus, minus 2h plus h squared, all divided by what? H. That's what I have left. That's all that I have left. And now, if I factored an h out of this top problem right here, I'm going to have this. Does everybody see what I have? I have factored out an h. Therefore, I can now cancel this, and now you have this 2x minus 2 plus h. Now what you actually have is this with this part right here. Is it okay if you let h go to 0? Back here, you cannot let h be 0. You see why? Back here, h cannot be 0 because it's where? In the denominator. But I suddenly did what? I was able to get it out of the denominator. And because of that, I wound up with this. And now I can now say, unequivocally, that I don't care if h goes to 0 or not. Let it fly to 0. It won't hurt my feelings or anything else if h goes to 0. So now if it does go to 0, then what you have left is this. Now that's a lot of work. That's a lot of work just to show one simple thing about that problem. It's a lot of work. It becomes compounded when it becomes greater than x squared. What happens if it becomes x to the 3rd power? X to the 4th power? Can you imagine taking a problem to the 4th power and plugging in x plus h and raise that to the 4th power? You'll be there for what? Quite some time working the problem. But doing this is defining for you actually what you're doing. And what you did by doing all this stuff here is you've actually calculated the slope of this line up there. You've calculated the slope of this line, x squared minus 2x minus 5. What can you say about the slope of that line? What can you now say about the slope of this line right there? What can you say about it? Who can tell me what you can say about the slope of the line x squared minus 2x minus 5?
It's 2 at some point.
It's what?
It's 2. It's 2. Wait, I don't know.
What can you say about the slope of
What can you say about the slope of my line?
x squared minus 2x minus 5?
Yes.
That you're gonna go down 2 over 1. That is
No.
negative. It's a negative slope.
No. Hold it a second. What you can say about the slope of this line, which is what? Which is this. The slope is equal to what? Does everybody see that the slope of this line is in fact this? Now what can you say about the slope?
That is 2x.
Look at it, look at this, everybody.
As X.
That for every X value, you change X values and you have changed the slope. So the slope is forever changing on that line. And if you don't believe it, draw a picture of this line. Draw a picture of this line. And it probably does something, I don't know what it does. It does like this. Something like that. I don't know where it goes down the other side, it goes back up, but I know it's like this. You cannot tell me that no matter where you stand, no matter where you stand on that line, you have to tell me, you know what? The slope is different than it was where I was standing a second ago. Just move another position on that line and tell me what. Yeah, the slope is changing. In other words, you could actually say the slope is increasing over here, right? Does it not look like that the slope is increasing, getting steeper? Getting steeper and steeper as we go up this side? Let me ask you a question. If you're coming down this side, what can you say about the slope of the line?
Less sleep and less.
Listen, you have to say that the slope is decreasing. It is a negative slope over here. This is a negative slope. This is a what?
Positive.
Positive slope. How can you, what must happen? What must happen if you go, yeah, I would put that away. What would happen, what can you say if you go from a negative slope to a positive slope? What do you have to say happens if you go from a negative slope to a positive slope?
Line changes direction.
There has to be like a minimum?
It changes directions.
Is what?
It changes directions.
You eventually hit no slope.
Exactly. You have to pass zero. If you go from negative to positive, folks, you can't go from negative to positive or from positive to negative without stepping on zero. Does that make sense? So listen, what does the slope of zero look like? What does a line with a slope of zero look like?
Straight line. Straight line.
It's what? It's flat. It's just like this. It's flat. So if you know the slope of the line that we've just drawn, if you know that the slope is what? 2x minus 5, that's the slope, then all you have to do is find out where is the slope equal to 0. Where is the slope equal to 0? It is quite easy to tell that 2x is equal to 5. X is equal to what? 5 halves, which is what? 2.5. Guess what? The first number of the vertex is 2.5. Because at the vertex, the slope has to be 0. At the vertex, the slope has to be 0. No matter if the vertex is up here like this, or whether it's at the bottom, the slope is 0. That's why I set the slope equal to 0. I wanted to find out, where does my line turn and go the other direction? Yes?
Would you use 2x minus 5 or 2x minus 2?
It's what now?
2x minus.
Oh, who did that? I got a bad marker. Y'all give me a second. This is supposed to be what?
Would.
It's gonna be 2 for 1.
We got it fixed now. Thanks, Mr. Wilson. Everybody see that? I copied it down on, I can't see the board down there, so. If the slope is 2x minus 2, then if I set it to equal 0, then when x is 1, then I can do what? I can plug that 1 back into my equation. I can plug the 1 back into the equation. And I get that point is 1 minus 6. Does everybody see that? If this is the slope of the line, and that is the slope, on this side of the 1, the slope is negative. Over on this side of the 1, the slope is positive. So how can I go from a negative slope to a positive slope? I had to do what? I had to cross the slope of 0.
Yeah.
Is that making sense? So that's why I set the what? That's why I set that to equal 0. I set it to equal 0. I wanted to see whether the slope was 0. Now, if the equations turned out to be third power, fourth power equations, you're going to have something that looks like this. Suppose that you had this. Suppose you had a line that looks like this. Guess what the slope is going to be for a line that looks like that? What do you suppose the slope is going to be for a line that looks like that? Who can guess what the slope will be on a line? Let me do another one. Let me get it better over here.
Will the variable be raised?
Hey, oh, hold on. Gee, what a sorry drawer I am. If you had a line that looked like that, okay? What do you suppose the slope is going to look like? When you calculate the slope of that crooked line that I have drawn on that board, what do you suppose the slope is going to have to be?
Something
The
square.
variable would be raised.
It's what?
The variable would be raised to a power of like 2.
It would have to be a power of 2.
Can I get some credit? I just said that.
Has to be what? To the second power, right?
Can I get some credit though, please? I just said that before he did.
Who cares, man?
Because I'm never acknowledged.
Shut up.
Welcome to life.
Is he gonna block? I'm just kidding. Go ahead.
Now, hell, you know what I feel like when you don't pay attention to me. Right? Oh. It would have to be, like you said, the power would have to be what? To the second power. Because why? Because there's 2 places that the slope is 0. There's 2 places. So the slope, the line, and the slope of that equation that makes it there would have to be to a second power at least. Because why? Because they are quadratics and they have 2 solutions. And so you would be able to find this point right there. That's the slope of 0. And there's another point over here that the slope is 0. Everybody see that? So if you have 2 places where the slope is 0, and you have an equation that equals to 0, it's got 2 answers, it has to be what? Quadratic. It has to be quadratic. Is that making sense at all? And you can imagine what it's like to have to do what? What if it has 3 terms in it, or 4? Even calculating the slope and the zeros of the slope. Where is the slope 0? If you've got a 4th power equation, wow, 3rd power is hard enough. fourth power equation, there's 4 places is what? It is 0. Is that making sense to everybody? Yes.
So by that logic, if you had an equation to the third power, that could actually be the slope of an equation to the fourth power.
Yes, yes. Yes, it could. Very well could. Listen, everybody. Why do you think they have you factor? Why do you think they have you factor? Because, listen, when you calculate one of these problems and you find out the slope is to the third power, you better know how to do what? Set it to equal 0. You better know how to set that third power equation to 0. Because you got to find the what? You got to find the 3 numbers that make it equal 0, because the darn fool equation turns 3 times. That equation is going to turn 3 times on you if the slope is to the third power. Because there are 3 places where it does what? And it turns, it goes the other way. That's why it's imperative that you know how to factor, not just for punishment. I mean, most students think that you factor till you almost want to throw up. But they don't tell you in the long run what you're doing it for. Because if you're studying math down the road, then you get to a calculus course, you automatically, they just expect you to do what? Factor these third and fourth powered equations to where you can find out whether they equal to 0. Because that you know what these points are called, folks? These points are called critical values of first order. Critical points of first order. Okay? And they are critical points. I mean, and let me say this, everybody. But they're going to tell you that this point right here, that vertex right there, and this vertex, it is a relative maximum and a relative minimum. Okay? Now let me explain to you what that means, because they do a pretty poor job in the textbooks of telling you why. It is too simple not to make it easy. I don't know why. Lord, I don't have a clue why they don't make it simple. All it means is the reason they call that a relative maximum point. Because look, do you see any other point on this graph that's higher than this one? Yes. It's where? It is way up there. There's another point on this graph. Do you see why that's relative? That is a relative max. Do you see a point that's lower than this point? Yes, way down here somewhere. So that means that this point is a relative minimum. Now, if you go back and they say, no, I am going to impose restrictions on you. I'm going to say point blank that you can only use numbers from there, whatever that value is, you can only use them from there to right there. Just these numbers in here is all the numbers you get to use on your equation, okay? So you have imposed a domain. Otherwise, the domain can be any real numbers in the world, but you sometimes have to go back and impose a domain. And when you impose that domain on this problem, guess what that's called?
Absolute.
An absolute maximum and an absolute minimum. Because, folks, let me show you something. That's the lowest point on the graph other than what? That one right there. That one is low. It is as low down as you can get. Over here, if that's the point, then this is what? That's the next height.
That's what? That's an absolute maximum. And you only get that by imposing what? A domain. Sometimes you have to impose a domain. Take the problem where we had what? This sheet of paper that's 12 by 12, a piece of cardboard that's 12 by 12. Okay, and you are to cut an X value out of the quarters, okay? You're to cut an X value out of the quarters. Well, guess what? There is a restricted domain in this problem. Because what? Try to do this. Don't cut anything at all. Don't cut any quarters at all out of the piece of cardboard. I promise you, you can't make a box. You're not going to be able to make a box out of it. And what has happened is when somebody said, "Oh, let me cut it for you. I'll cut the quarters out of it." There it goes, right there, 6 by 6 out of the quarters. You got what? You got 4 pieces of cardboard. You throw in the trash. You have no box. So that means what? There is a restricted domain on no problem. You have no control over that. That X value that comes out of the quarter has to be a number between what? 0 and 6. Cannot be 0 and it cannot be 6. Has to be, that's why I didn't put the less than or equal to. See this? So if that's the case, it says what? That somewhere along the way, between 0, in other words from 0 to 6, somewhere there's a what? There's a magical point that I can cut out of the quarters of that box that will produce the maximum volume. You can either cut little tiny X's out of the quarters. The box will be fairly what? Wide and long, but it won't be very deep at all. Or you can cut fairly large X's out of the quarters, and you'd have a narrow box this way, sort of long and narrow like this, but it would be what? It'd be pretty deep. So somewhere in between that, there's got to be a point that's what? That says it's a maximum volume. That's what calculus is all about, is minimum and maximum problems. And it makes life so really, really neat when you're able to apply calculus to the problems, and you'll see how much easier it makes the problems. Just applying a little bit of calculus to it. Taking a calculus problem and showing that you've got a piece of wire or whatever, a string, you can literally show if you make some type of figure with this thing, putting it in a circle will maximize the area. It will maximize the area. Now, let me go back and ask you a question about this problem over here. You heard me mention about this thing having what? Relative max, relative bend, okay? And we also found out we had a relative max and a relative bend of what? Of first order, okay? Does that mean that there's a second order somewhere? Yes, there is a second order, okay? And that second order, if you will just look at this picture, and I know my picture is sort of poorly drawn, but if you look carefully enough at this picture on this side, this is obviously something that will not hold water. As analogy, do you see that that won't hold water? But if I'm looking at this side over here, this appears to hold water. That makes sense? I mean, if you just look at it, holds water, does not hold water, right? So my question is, gee, where does it go from not holding water to holding water? Where does it go from not holding water to holding water? Somebody please tell me. I don't know, look at me, I don't know either, because somewhere along this spot here, okay? Somewhere with these numbers along in here, that it goes from what? Not holding water to possibly holding water. Now there is a magical way that you can find that spot. It's called of second order, okay? It's applying the same principle to the slope as you did to the other one. Where we did what? We found the slope. In other words, think about this. You found the second slope. You found the second slope. And that's where it goes from. That magical point is called critical point of second order. It's located there. It is quite easy to find. It is quite easy to find. Critical point of second order. So in other words, the book will put it something like this, going from concave downward to concave upward. And there's a couple of different things you can apply to that. If you say, well, it's a concave upward, okay? If you look at the slope of your line over here, the slope is increasing, 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 increasing as you somewhere go along here. Then suddenly the slope becomes 0, and then the slope starts doing what? Negative. And suddenly it does what? It flattens out again and starts to increase again. So you literally you can do this under the interval notation. You can say from minus infinity up to this point. From minus infinity up to this point, the function is increasing. If you don't believe it, look at it and see if it's not increasing. It's getting what? Larger, larger, larger. So from this interval back from this point up to here, it is what? The function is increasing. And from this interval to this interval, the function is decreasing. And from this interval all the way up to infinity, it is what? The function is increasing. Is that making sense at all? And that's looking at it from an interval notation rather than any other way, just an interval notation. You just look and say, okay, from minus infinity up to this point. Okay, now, if we just stop a second or two to talk about this problem, you've seen this problem before. The one you looked at before had a minus 16, right? And that was indicative of the part that doing what? That's being thrown upward, because the minus means what? That the gravity is working back against you. So now in this case it's what? It's positive. It means that it has been thrown downward at what? At 8 feet per second. Somebody, they didn't just drop it. If they dropped it, then this part would be what? Wouldn't even be there. But this is indicative that they're throwing it downward at what? 8 feet per second. Now, if that is the height that the object is falling, so if you knew how many seconds go by from the time you threw it out of the helicopter until you watched it hit the ground, and let's suppose that it took 4 seconds to do that. How high are you in the air? How high are you in the air? It's a very simple problem. Work it. It's just a very simple problem. Work it. How high are you in the air if it took you 4 seconds to hit the ground? Who's got the answer?
288 feet.
How much?
288
288?
feet, yeah.
Yeah. Did you tack on the 32?
What's 32?
The 4 times 8.
Oh, yeah.
You did?
Yeah,
You tacked that onto it?
yeah.
Anybody else get the, you said it was how much? 288?
Yeah.
Got 288? Anybody not? Well, somebody did you not get 288? You got 2? You got 288?
Yeah.
Got it? See if you listened to what I've told you already, okay? We'll see how many of you has listened to what I've said today. How fast is it traveling after 2 seconds? How fast is it traveling after 2 seconds? And you better not mess this up. How fast is it traveling after 2 seconds? Y'all hurry up. Do the calculations, hurry. How fast is the rock traveling that you threw at 8 feet per second after 2 seconds?
40 feet per second?
How much?
40 feet per second?
16 feet a second.
16 feet a second?
How much?
16 feet a second?
I got 40 feet per second.
I got 40.
Oh, you said 2 seconds to the
No, that's for how far, not how fast.
Yeah.
Your equation's for how far, not how fast.
It's what?
That might be right.
The equation's set up for how far, not how fast.
Who said that? Mr. Flowers.
Whoa.
Whoa.
Jeez.
What are you? What have I been talking about all afternoon?
Dang, came here to learn. I get screamed at. Man.
What he's saying is, did y'all hear what he said? Of course, it's obviously that's what it's set up for, right?
Yeah.
But guess what? Guess what?
That's not what he
A
asked.
quick manipulation will give you what?
How
The
fast?
damn slope. The slope. You know what the slope is, everybody?
The velocity.
Rise
It's
over.
velocity. Aha. Aha. You accused my equation of wrongdoing. Good grief.
Gotcha.
My equation is not wrongdoing.
Gosh.
But you ain't, that's exactly right. It's what? It is what? The equation is about what? Distance, right? So listen, the slope, you think about this a second. That's related to time also, right? Distance and time. You do a change in distance divided by the change in time, and what do you get?
Yeah, definitely.
You definitely get velocity.
Definitely should have.
And that's what we get when we do the first derivative.
Yeah.
And that's what you've done, you applied that what to it? The slope to it. If you apply the slope to this problem, You're gonna get 32t plus 8. 32t plus 8. What, Mr. Wilson?
Yes, sir.
Oh, yes, no, you know, I showed you yesterday.
I know that, I done it.
You remember doing that yesterday? Yes, you did, the day before yesterday.
I did that on so, I did a derivative on so many of my test problems, so I can't believe I just messed that up.
Yeah,
Like,
it's
God.
32, it's, yeah, I was going to say, that's why I jumped up and down. But you know, look, that's what it is, the 32 t plus 8, right? And you plug in the 2 seconds. And I don't know what's 2 times, what's 2 times, 32? 64 plus 8 is how much? So, guess what? Yours was wrong. But now you got it right, is what?
72.
Listen, at that very moment, 2 seconds, not 2.1 seconds, 1.9 seconds, but exactly 2 seconds, it is traveling 72 feet per second. Does everybody see how he did that? We applied the slope formula to this thing, and we actually got 32t plus 8. Now, you're wondering, I bet, you're probably sitting there going, how in the world did he do that? I went through this process of x plus h, y'all remember that? H plus x. No, I didn't either, because all I did was I did this. I took the 2, and this works, by the way, and I can show you and prove it to you. And if I bring the 2 down, that becomes 2 times 16 is 32. T, take 1 away from that number and you get 1, plus, you take this 1 and put it down in front of the 8, you get an 8, and you put a 1 away from this 1, you get a 0, and what's T to the 0? 1. Everybody see that? So there's your answer. This is what? That's the velocity. It's 32t plus 8. And all I ask you is how fast was he going after 2 seconds? Right? Why?
If there was like another number, like say it was 16t squared plus 8t plus 5 or whatever, could you still do it like whatever number it is?
Yeah. You're just standing 5 feet higher than what you were to start with.
Okay.
Forget that. Just forget that. So it's not going to be
Right, so, but like at any time when you have, so instead of.
Okay, here we go. You're standing on the edge of a cliff, okay? And you throw it off. There it is, right there. You throw it downward, but you know what? You actually got up on a platform 5 feet high.
Yeah.
And you threw it. Duh! What difference is that going to make?
Well, I'm just asking, can you do that little trick with
Yes.
anything? Okay.
What about if like you're throwing it out and then?
Oh, you throw it out this way? Aha! Aha!
Oh, yeah, you're right. This
Aha!
is gone. Yes, there's a way.
I don't suppose y'all seen my demo that I have. I made a demo to prove this, and I built it, and it's in my shop at home somewhere, I think. But I built, it's something that looks like this. I put it up towards the ceiling on this side of the room, and across on the other side of the room, I put a steel tin can. It looks like this. And across the room, I have